I welcome you all to our Certified DevOps Engineer Live Free Training Program. This is our roadmap, and according to it, we have completed day 1 to day 5 very successfully, and we received very amazing response. We are thrilled with that. And today, we are going to start day 6 containerization. For those of you tuning in later, don't forget to mark your calendar for our next free live training session. We have updated our training registration process. Instead of QR code, you will now find a direct link in the description or comment section just below the title of this video. Once it is uploaded to YouTube, simply click on the link to get started like this. Would also like to acknowledge your kind support and love, which inspire us to continue providing this valuable training opportunities. Thank you very much for that. If you would like, feel free to connect with us on social media. We'd love to stay in touch. So before we sell our Kubernetes chip, let's first pack our containers. So this session is divided into 4 parts. We'll start with Explorer section, which is completely foundational. Then in Navigator part, we will install Docker and run our very first container and learn all the commands to get started with the containerization. In Builder section, we will learn how to create our own Docker images from the scratch. We will not only learn how we create images with the Docker file. There are several ways, and I would be explaining you in this section. This is really gonna important because that's what as a DevOps you are gonna do, or maybe as a developer. So you must know how to create your own Docker images or container images. Finally, we will dive into advanced skills in Captain section. And of course, this is so without further ado, let's see what we are going to cover in Explorer. So in this, before we go ahead and get our hands dirty, so first we will see what containerization actually means and what happened before when the container was not there. So I'm not going, or we will not go into the history, but this is really important to know. So it will give you better perspective of the container. Okay, and then we will see about the virtualization versus containerization. What is the difference when we follow this virtualization or containerization approach? Then we will also see virtualization versus our setup, and then we will see what container engines are. After that, we will start to what Docker is, then how Docker can help us, and then we will also look into the Docker architecture. So all these things we will cover in this section. So let's jump into the first part. First thing first, what container is. So to understand this, let's consider one scenario. We have one application, and that application, let's say 3-tier application. You could say the presentation tier or simply front end, and then you have back end, which is application tier, or maybe some your application logic, and you have database. So you have one application which you want to deploy. For front end, consider you have a JavaScript based application, okay, and you need a node to run your JavaScript. And for Java, you need a Tomcat. For database, you are using Postgres. So this is your application is already built. Right now, this application comes to operations team. I'm not using DevOps at the moment, so just consider operations team. Okay, so or the deployment team or release team, whatever. Team has to deploy this application, and to deploy this application, we have several ways. So let's first see the traditional way. What happened in traditional application deployment way, or in this approach, the operation teams start working on configuring the servers. For JavaScript application, they have a dedicated server. After installing the operating system, they install all the dependencies, library, node app, or whatever required on this server. So they configure this server. Then after that, for Java, they took another server and configure everything on that and make this server ready. It can be one, it can be many, depending on. So I'm just considering in this is 3-tier. So in production, we as best practice, we keep our code separate, right? So for that front end, we have one server. For backend, we have another server, and similarly, database team is also started. So let's say these things are done by the Linux team. They prepare the server, and after that they send it to the ops team or operations team. After that, they will prepare and configure the further application on top of this server. And similarly, meanwhile, Linux team also configure Linux server and server provided to the data admin team, right? And they started to configure the data for the application. And in this way, this is what happened in the traditional way, where for each and every application, you need to provision or configure or set up server for each and every tier depending on use case to use case. So it could be one server, it could be managed server, right? So it's typically happen in the traditional environment, which is straightforward, nothing is special over here, right? Then what happened with this approach? You need a multiple servers. For database, you need a very bigger machine. For application, you comparatively the resource consumption is less. And maybe for presentation, it might be possible these and this server can be have same configuration, right? But when we deploy the application, it might be possible the resource utilization is not proper. This is one of the problem. Second thing, when these are configured, so inconsistency within in the environments, right? And complexity in terms of dependencies management. So this is what happened. Additionally, we also have to maintain separate server. Because of this, we came up with another approach, and that approach was the virtualization. In virtualization, what we do, we have a hardware layer, or hardware layer, it means our servers or machine or whatever. So we can represent that all our machines as a hardware layer, right? And on top of that, we have operating system or enterprise level server. So instead of operating system, you directly install the hypervisor on top of the hardware, and then you start creating a virtual machine. But in our case, right, we talk this in our day one part one in very detail, what is virtualization, right? So let's say we have hardware, on top of that we have operating system, and then we install a hypervisor, and using the hypervisor we are creating a virtual machine. So instead of creating three physical machines, right, on the same machine we have created three virtual machine, one for our front end, one for the back end, and one for the data tier, right? So this is what we have done, right? We already talked this in our day one very detailed. But in this case, what happened when we create this virtual machine? So each virtual machine has its own operating system, it has its own binaries, it has its own applications. It's isolated from the, this is our host operating system, and these are isolated using the hypervisor. So instead of creating or buying or provisioning multiple servers or physical machines, we can leverage the technology in a way that if we have big server, we can utilize the resources of those machines in that way using the virtualization, right? So this is the very simple approach. So instead of configuring multiple machines, we are creating virtual machine, right? So virtual machine is a one way by which we can utilize the underlying hardware resources very conveniently. So this is the virtualization. So now question is, what happened in containerization? What is the deal? Not the big, but what is the deal with the containerization? So in containerization, we have the same thing, hardware layer, operating system layer. And on top of that, we install container engine. A container engine help us to create containers. So similarly, there we were creating a virtual machine. Here we are creating a container. So for node application or front end, we could say, okay, container front end. For backend, we could say the container backend. And for the data, we could say the Postgres or data container. In container, we don't create the operating system at all. We only create a container. Okay, so let's first see the difference. We will see these everything in the action. Okay, but remember, when you create a container, it doesn't mean you are really installing a new operating system. Okay, so instead of that, you are running. Okay, so what container it means, we will come on that, but first we see the containerization. So before that, let's first see what happened with the virtualization and containerization. Okay, so in virtualization we had the hardware layer. In containerization is also the same, right? Operating system layer is also the same depending on the use case how you set up. But for this, or for time being, consider on our machine we have hardware layer, we have our on operating system, and on instead of hypervisor, we install container engine. Okay, and here when we install hypervisor, so we are creating, and we know we saw a entire process in day one part 2 how we can install the operating system in virtual machine, right? So basically what happened in virtualization, it is a interview question. Okay, so here the in virtualization you do the virtualization of the hardware. Okay, each virtual machine has its RAM, its memory. I mean, of course, RAM. I mean, I'm talking about the storage, okay, and processing capacity. So let's consider these three things. Of course, network components are also there, and similarly, this virtual machine has also its own, okay, its own resources. Similarly, this machine also has its own resources, and they are completely isolated. Okay, they cannot, or they are not sharing each other's resources. So let's say this virtual machine, you use one CPU or 1 GB of RAM, and for this you used two CPUs, 4 GB of RAM, and for this you use 5 or 4 CPUs or 5 CPUs, whatever, and 10 GB of RAM. So whether these resources are being used or not, these are allocated to this particular virtual machine. Okay, so in terms of resources, they are not, I mean, if you go underline, yes, but we have reserved, let's say, so they do not share the resources whatever assigned to them or allocated to them. Additionally, they also not share the operating system. So it is completely, we can say, they have their own operating system. Okay, in case of container, so container also does the same thing, virtualization, but it doesn't virtualize entire operating system, or not the operating system, it doesn't virtualize your hardware. Okay, here we are creating, or we were creating everything, RAM, memory, storage, network, everything in the form of virtual. So that is your hardware virtualization. Here what we are doing, we are also doing the virtualization, but here we are doing the kernel virtualization. Okay, so when it would be asked in the interview what is the difference between virtualization and containerization, so you could say virtualization or virtual machine, or this is more the hardware level virtualization. Here you could say more kernel level virtualization. So we will go more deeper into when I will show you in part 2, but for now it's enough to know, okay, container is also one kind of software that also does the same thing, except installing the entire operating system we create the container. Okay, so this is what happened in containerization. Okay, and this is our setup what we are going to use. So in our case, we have our own machine, right, our own laptop, we have operating system, and on operating system we have one virtual machine, and on virtual machine, okay, this is Ubuntu, and then you have container engine. Okay, and then we will be creating the container on top of that. Okay, this is the very simple setup which we are going to do, and it's the same thing. So maybe now I strongly believe now there is no more issues to creating a virtual machine. When we started first time, you might be wondering, oh god, what is this topic about, right? But now you are very familiar with that because you created lot of virtual machines already. Similarly, in container it would be same, or I would say it's very easier than the installing and creating a virtual machine, right? So that's why in virtual machine you install the operating system, and here in containerization, instead of installing the operating system, you create the container. So here the question is what container means. So container, it's consider it as a the isolated environment. Let's say you go to a restaurant where you have a buffet, right? So you are on, if you are vegetarian, okay, it might be a bad example, I don't know, but just kidding. So you will only pick up the vegetarian food, right? And if you like to eat other way around, so you pick up those things. right? So similarly, in case of container, we do the same thing. Okay, we really don't need all the functionality of the operating system. Okay, we only need some of the functionality. For example, to run the JavaScript application, I need only Node server, right? I don't need at all the Java or Tomcat or need to be installed on database on this, right? So I'm only creating, so this application considered as a one task, one process. Okay, so that's why I said revise day 3 before this. So when we run this command ps-aux, right, where we can see all the processes, or I would say let's see this in action instead of explaining you in the theory. Okay, so do you have any questions on this? No. Okay, okay, friends. So, okay, Anish. So here I was mentioning the container engine, right? So for container engine, we have many things. So we have containerd, we have Alexi, we have Podman, and Kubernetes main job or main primarily it is for the container orchestrator, but it also interact with the container runtime. Okay, so there is no harm to consider this as a container engine, right? And of course, Docker is also one of the popular container engine available in the market, and which is the leader, and that is what we are going to, or that is our main topic for the day or focus of the day, which is Docker. So that is our next topic. So let's first see what Docker is. So instead of going here, let's me go back for this to the Docker website, and we already saw here, right, in our presentation what container engine does. So yes, Docker is a container engine, right? And if we see the official definition, and container engine help us to create containers, so that is actually I would say that that's according to me, but official definition it's more, right? It says it's open platform for developing, shipping, and running. So we know what development means. We will see shipping means in when we go to the next section, navigator, right? When we do hands-on, we will see how we ship. So here shipping, it means instead of, so for example, in previous I was showing this diagram. So instead of installing the application on the physical server, you configure the container, right? And you can share that container within the team or to whoever you want to. So that is shipping and running, and wherever you want to deploy, so you could easily deploy because all the dependencies are inside the container. It's very similar if you take an example of Java, right? So everybody says Java is platform independent. How it is? Because in background, right, we have Java virtual machines. So that, so if you're installing on Windows, you have to install JVM for Windows, right? Similarly for Linux or Mac. And in front end, whenever you create a code and compile, it creates a class file, and that is understandable by the Java virtual machines, and they do the rest of the work, right? That's why it says it's a platform independent. So platform independent for the user because they have created something in between middle layer, and that is Java virtual machine. Similarly, here is also the same thing. Instead of deploying the entire application onto the server, there is a layer in between, right? That is a container engine that facilitates everything. So inside that, we put everything, okay, related to the application, whatever need we do, whatever we need. So let's say for one of the container, we only need to use vi editor. To use just a vi editor, why should I have to consume lot of resources of the server or virtual machine, right? So that is the one of the thing. And running the application, so you can run anywhere, and yeah, you can read about it more on this page. What I would like to show you is the Docker architecture. Okay, let's open this in a new tab. Yes, I didn't create because I like this diagram very simple, straightforward, easy to explain. So there is no point to recreate it, right? Or redraw it. So it's already drawn by the Docker. We thank to them. So let's use this. So when you install Docker, so Docker has some components. One is client, one is host. So you could see this is completely based on the client server based architecture, or you could also see the Docker uses client server architecture, right? So Docker host consider it as a server, and Docker client is where you are actually executing a command. So for example, to access this website, okay, this browser, right, this Safari browser is my client. Okay, over here I type this docs.docker.com and I'm accessing this image. So this image is actually on my system? Is no, this is somewhere on the remote server. So to use or to access this image from the remote server, I need some mechanism, and that mechanism is browser. So this browser is client, right? So similarly, to interact with the Docker server, we need something, and that something is client. Okay, we will also come on this point what these are. Okay, and after that we have somewhere remote where this image is stored. Consider that server, just as understanding, as a Docker host. Okay, and we also have this registry. So there are three things over here. First is client, second is Docker host, and third is registry. And each and every this, I mean, these are the three things, or I would say the three columns or three components or three parts. There are so many others as well, but on high level overview, you could say the architecture is divided into three things. First thing is your client, second thing is your Docker host, and third thing is your registry. So client, that is what we use to communicate with the Docker server. Okay, and instead of calling the Docker server, of course it's a Docker ecosystem, they want us to call this a Docker host because they have given it a name, right? And it is also good we know the terminology, because when you work in the company and if something happened, okay, and somebody saying, okay, Docker host is not responding, so you know what the person is talking about, instead of saying Docker server is not working, right? So that's not a good idea. So that's why it's a Docker host, right, where actually everything happened. Another important component here they mention, it's a Docker daemon, right? So Francisco, now right before the session we're doing the troubleshooting and we are starting and enabling the services, right? So in Linux it is called the daemon. So daemon service, we could say the same. Okay, but yeah, so here the Docker daemon is a special kind of service inside the Docker host. Okay, and the client, so for example with this browser client, when I execute, or yeah, Noham I could say execute, or when I type docs.docker.com, then this browser understand this HTTPS string, right? Similarly for this client, it understand this string. So for its, or for client, Docker run consider is as a HTTPS, okay, slash or colon docs.docker.com. So I mean, I don't know how much this example is correlated, but just to explain you, client, it means it is understand the Docker commands. Okay, and we need a client to communicate with the Docker host. We will go more deeper into, I will break this down more in part 2, but this is the high level. So let's understand client to communicate with the Docker host. Okay, and these are the just commands, so ignore them for now. We are going on this very shortly. So when you run, or when you execute Docker run command, then this command execute are going to contact on the Docker host, and on Docker host it is going to communicate, or these are received by the Docker daemon. Okay, so Docker daemon is very important component. Okay, and which runs the container, which builds the container, which pulls the images. So you could also see there is an image over here, and the same option image over here is also. So don't consider these and this, but just consider this upper one, the image. Okay, so registry, it means like when we learn this GitHub, so we saw GitHub is a cloud kind of platform where we put our code, right? Similarly in Docker, to store the images we have some place, right? And that place is also provided by the Docker. There are so many others as well, but in this case it's a registry. Okay, and they call this as a registry. And in on the registry you could have several images. Okay, and this arrow represent, I will again come back on this point once, but just for time being, let's say uh, you are running a container, so it finds it go, I mean docker daemon goes and see, okay, images, if any image is available, yes, image is there, and it runs the container for you. When you build, it says, okay, I have to build the image, and it builds the image, right? And here additionally, I'm not gonna explain this for hold, I'm holding on this dash line. Okay, and when you pull, so we know similar, there was a command in git pull, right? So we have to download. Similarly in docker pull is also kind of same command, and you could see this is directly going to the image, so image registry, I would say. Okay, or simply registry. Okay, if image is not there, it contacts, or it goes out, okay, out of the docker host and contact the docker registry. So there are several registries available, but we are talking about docker. If you don't specify anything and you install a docker, so by default docker daemon consider, okay, I have to go to docker registry. Okay, so docker registry is one of the place somewhere on remote in the cloud where we store all our docker images. So we will also building our own image. We will also see what container is in action. Okay, so this is high level overview. It is three component, or not component, three parts. One is client, one is docker host, another one is registry. And remember, this client and host can be on the one machine, okay, and both can be on different machines. So if you have very big workload, so you could install, right, docker host on maybe centralized server, and rest of the team member or company member can be accessed from their local system to that centralized docker host. Okay, so depending on the configuration, but in our case, or in your case, when you install docker on your system, this both will be on your local system. Okay, so we have client, we have host, okay, and then we have registry over here. That's three components enough. Do you have any questions on this?
All good.
All good. Nice. So I think that's enough for the theory. Okay, and that is also end of the section. Let's see what we have. So this, here we are, and then we have this. Okay, so in this we seen what is containerization, what is traditional way of the deployment, virtualization versus containerization. Okay, and our setup, what are the container engines available. Docker is not only the one, but docker is the one which we are going to learn. And we also saw why and docker architecture. So I know this is more on the theory part, but I think this much in a theory is enough. I will, or I would, but anyways, I don't want to go much more into the history and what happened and when happened. If you're interested, go ahead and read that. But from my perspective, my experience, this theory is enough. Okay, so this is what we covered so far. Okay, so now we will go ahead and see our navigator section. So in this section, we'll go ahead and install the docker, right? Then we will do the post configuration, then we'll create a container, then we'll create and run the container. Okay, we'll also see what is this difference, create and run. Okay, then we'll pull container images. We will also list the container and container management, and as well as the image management. So that's everything we will see. So this is completely hands-on. Okay, so let's directly jump into our terminal. Okay, so it's a different machine. Okay, and good, let me run my favorite command so I can show you same, but you may already guess by this. Okay, username and symbol. Okay, so I just gave it a workstation one, and yeah, these are three. Okay, so what I will do, we will first install the docker, and the architecture diagram which I explained you, we will see each and everything over here. Okay, so for that, the docker documentation is again awesome. Okay, you could type directly Docker installation and you will get everything, or the first link, and click on this once you come on this. Okay, so there is option install, and you can also see it says Docker engine, right? Similarly, I mean, of course it's a Docker product, so that's why it is Docker engine, but for the creating a container. And go ahead and also learn about the licensing if you're using it for commercial purpose. And in installation section, okay, here the thing, always remember the installation of the Docker. Okay, there are two ways. So let me go back over here. So you could also run this command. Let me make it a little big, 30, I think. Yeah, okay, that's enough. So there is one option. You can also install you can also install Docker using sudo apt install docker.io. Okay, and it will install Docker for you, and it will ask you, prompt you, if you don't want to, or if you're sure you want to go ahead with this, so go ahead and install with this. This is one of the way to install the Docker. Okay, let me copy and paste this command to you, share, if you are following along. So you could use this, or this is one of the way, second way, which I'm going to show you. So what happened in this case when you install using this, right? So this will be downloaded and installed from the apt repository, which is maintained by the Ubuntu or apt repository maintainer. Okay, which might be, but I'm sure which will not be a latest version which we are going to download. Okay, so for that, what we can do on this installation section, right? We want to install for the Ubuntu, and there is also Debian, but we want to install for the Ubuntu. Click on this, and of course there are prerequisite. Go ahead and read this. I always emphasize on this before going to install. Understand what's their requirement. Okay, it says OS requirement, so these are the OS requirement. It doesn't support Ubuntu below than 20, I believe. Yeah. Okay, and also compatible with this one. Okay, ARM, so which is my processor. Okay, because I have installed on Mac, right? So I'm based on that. But if you are on Windows virtual machine or physical laptop, you are really good with AMD 64. Okay, and of course older versions are over here, but we will go ahead a little bit down. Installation method. Here again we have installation method, and this installation method, we know, we already of course several times discuss about this, right? What is this? So in this case, what happened, of course we have to update, we have to install this, we have to change this key rings. Okay, and curls and this one. So same we did for the Jenkins. So and after that we echo, and echo will do all these things, and this will come in Docker list. So I showed you already before what this commands for. So basically here we are adding a repository. In short, they also mention, sorry, setup Docker apt repository. Okay, so I will simple copy and paste over here all the commands. Remove this and I hit enter. It asks me for the password. I'm gonna do that. But I think I forgot to mention one thing. Mhm. It says here, run the following command to uninstall on conflicting packages. So let's first do this. And if you see here, I mean, if you notice, so you could see docker.io. Okay, and here it says podman docker. So it says conflicting packages. So conflicting, it means if you have this, so it will, when you run the container, because both are the container runtime, right? So there might be, not might be, there will be a possibility where your container will not run properly. Okay, so that's why, let me remove this first as well. So I will copy this and say, okay, let's see what do we have. Okay, and Additionally, don't ever execute this command. Okay, apt auto remove. It will.
Sorry,
Yeah, Francisco, go ahead, please.
the connection. Sorry, what did you put in the terminal? The last command.
Which here? You mean right?
Yes.
Okay, so from here in the documentation, what I have done, I have just copied these commands over here. One second.
Okay.
One moment. We have somewhere. Yeah, theme. Okay, now it will make more sense better. Yes. Why?
Yeah, this large command. Yes, I did it. Yes.
Yeah. So it says before installation, it asks us in this point, run the following command to uninstall the conflicting packages. So these, they have already given us a command, and it is kind of one-liner shell script. It does not, I mean, it does the for pkgi, and it finds all for all these things. It perform apt remove, and this is the pkg, okay, which is the value of here. So it's a one-liner kind of a script. Okay, so let me clear the screen again, and I copy this. So let me make a little bit small, so maybe it makes more sense. And this command, right now we are going to execute, and it will perform everything for us. Okay, so all good. Okay, it has done, executed successfully. Now we will go ahead and do the installation method. And installation method, we have many other things as well, right? We have docker desktop. We are not going to talk about that later. Maybe we'll do at the end of this. Okay, but our use case is different. We are more focused on this manual installation. You can also have a script which is over here and explore, but I'm giving you the manual way. Okay, how you could do manually. You once you understand manually, you could also explore the scripted way. Okay, so what I will do, let me clear my screen. Control L, Control Shift V. Now it says add here. Okay, add official repository, so which is done. Then we have a next one. If you have a specific requirement, go ahead with that and install and download that version. Okay, if not, we are just learning. So here there is a button, it's here, right? Click on this, so it is copied. I go ahead, clear this terminal, and again I paste it. Okay, so it's already says upgraded, the following packages were automatically installed, and this already newest to the version. Okay, so it's already installed, I already did that. And what else we need to do? Then after that, we have to run this command to check whether our docker is installed or not. So it says okay, docker is already installed. Before going to run the container, we will first check. Okay, and what we will check, we will check the version. Okay, and before that, what I will do, and here there is a, I mean, this command we will execute but in different way. So let me run the sudo, and very first command I will say docker dash dash version. Okay, so my version is docker version 2.8.0.01. And if you will be installing your docker using this command sudo docker.io, I mean sudo apt install docker.io. If you go ahead and install with this, so this version, I mean version after that you execute this command, okay, so you will not get the latest version. Okay, so but that version is tested, okay, by the apt repository for their on this ubuntu 24 by version, but this version is already tested by the docker team, and they for sure for their on, so okay, it is gonna work. But you need to check what you want to install. And additionally, how you can check, of course here I know which operating system I have installed, right? But there is a one option, etc cat os release. Okay, so when you execute this command, by which you can identify which operating system you are using. So of course it's ubuntu. Okay, this one is this one, and here version. Okay, so by which you can identify which docker version you have to install, right? So this is one of the thing. Now we have checked the version, and we have checked the version by this command. Okay, there is one more command to check this, okay, which is docker, and then we have, so instead of putting dash dash, I'm just executing this. So I know, let me minimize or fit this into the terminal so I can explain you better. So before I executed this command, I think we can, okay, yeah. So if you see, I just executed this command, docker version. Come on. So yeah. So here we can see two things. So first thing is client, okay, which is over here. Let me zoom it one by one and we will see. Okay, so here, when first we saw the version only when we execute the command but without dash, okay, then you see the version client, and you could see the Docker engine community. So Docker has two line of products. So one is community, right? One is open source, or I don't know open source is right word or not, but I would say the community version, and second one is enterprise version. So we are using community version. Okay, if you are on enterprise, you will be able to see the other thing as well over here. Okay, then this is the version of the client 28.0.1. Please make yourself familiar with client version and server version, because this is gonna be we are using for Kubernetes as well. Okay, and here also the API version. So what API means actually, so in Docker, right, when we execute any of the commands, so for example I executed this command, it means it has contacted in our this diagram, that is this, right? So instead of Docker run, I executed Docker version. So Docker version, when I executed command on client, it going to, or it went to Docker daemon and contacted a Docker daemon, and then Docker daemon responded this information. Okay, so that's why this is our client. So where we are executing the command, we are executing the command at client. Okay, and in this case, of course this terminal is my system, but when you execute this command, so yes, you can see Docker client, sorry, Docker client is also installed, right? You could see Docker client is already installed over here. This is the version, and you can see Go version, right? So this is developed over here. This is the Git commit. Okay, this is the build when it was built 26 February, and it says ARM. So you know, I didn't explicitly specify, I just copy paste the command from this documentation. Okay, so whatever your operating system, so it is smart enough, it will automatically, that's why we created a repository. Okay, so when we create repository, then we runs update, and after that when we install, so based on the our existing architecture, okay, OS arc, so based on that, it will automatically fetch the corresponding components, okay, or corresponding version, and install it. Okay, so you probably find it over AMD 64 if you are using 60 uh, I mean any other operating system, right, 64-bit, but in my case it's the ARM 64. Second component in the same command which we have received, it's a server. Okay, and here again it's a Docker engine, same, but what is difference? Engine version is also same, API, go, git commit, build, or is same. Experimental false. So experimental false, it means we have a stable version, and if we go over here, right, so latest version it says. Okay, if you go, I think somewhere, I don't know, yeah, there is somewhere, but it's fine. If you are interested in experimental, so that the step, if you are not, if you don't install, or if you are not going to install a stable version, then it will be experimental, true. Okay, or maybe you're exploring or trying out what happened, and then after that you want to give a feedback. So remember, that's how you can chat. Okay, it was interview question for me when I very first, not very first interview, but in one of the interview. Okay, yeah, ask me how you can check the which Docker host you are using. Okay, I mean the exact question I don't remember. Of course, it's a long back, but this was the question: how you can identify whether you are using stable or which version you are using, right? So of course you can see version, but you should also mention this thing. Okay, I asked back a question to the interviewer, then that guy told me, okay, when you run this command you have this option. Okay, so that's why I remember it. But here we also have container D. Okay, and we also have run C, and we also have Docker in it. Okay, so there are additional component in comparison to our client, right? So uh, yeah, we will also talk about this context in our when we go to the advanced part. Okay, but for the moment, just to know context is something where we are working on. Okay, and here what I was talking about, yes. So apart from this, so all, I mean, till here everything is same with the client, but here server is a special, so it has container D. Okay, and here I was referring Docker daemon. Okay, so we'll talk about this, but just see and keep in mind. Okay, uh, there are additional components, right, of the part of server, right, or Docker host. It's a container D, run C, and Docker in it. So you can also check this. Okay, so this is one command to check the version, but it gives you more information. Additionally, one more command. I know it's much, but these are really really helpful to you to better understand the Docker ecosystem. Okay, and when you execute this command, then what happened? Let's reduce the font. So when we run Docker info, then we have more details, right? We also have plugins, compose, right? And here we also have the same thing, plugin somewhere, right? Here and here. But let's not go to the mm, again the architecture diagram, but simple. In client, when you go ahead and execute this command info, you will get more information where you could see build x, compose, right? We will see the compose in our builder or maybe captain section. But yeah, just to show you, you can play around and you know what are the things which we have with the Docker. Okay, and the server, and you could see we do not have any container, we do not have any running container. Okay, pause to stop images, it's saying two images are there. Yes, that's correct. I have stored some of the images, and yeah, there are so many other stuff as well. So from here we have volume, network. We will also see how we can see the network, how we can create the network, and yeah, there are so many other stuff as well. So on Docker installation, I believe this is enough, and these three commands are really really helpful. I don't know when you came across you, but you need to know. Okay, there are three commands. Okay, by which you can see the kernel version, operating system, all these things. Okay, so first command here I told you it's about the dash dash version. Okay, this was the first command, right? Then second command was the version, Docker version, and the third command was this, the Docker in sorry info. Okay, so we have only these three things. All right, so in for installation part, I think this is enough. Thank you, Francisco. So if you have any questions, I know I took a little bit, or I spent a little bit more time over here, but it is important, that's why. Okay, I believe ready. Yes, yes, we'll do that. Okay, so this is the one thing. Once you install the Docker, after that, and you maybe I don't know, realize already, for this I use sudo. Okay, and for this I didn't use sudo at all. So what I have done over here, so this is our the next thing, and next thing is post installation configuration. But before that, I would like to show you something. Let me, okay, not clear the screen, we are continuing over here, sudo and systemctl, and how you can check the status of the Docker service or Docker daemon. Okay, so type this, you could see the Docker is up and running. So let me make one thing, clear the screen, and let me stop it. Stopping Docker service trigger to its are still active. Okay, anyways, noise. And now again we see, okay, it's done, it's a stop, and quit, and let me run the again the command. This one, yeah, but let's stick with this Docker dash dash version. Okay, it's showing. That's fine. It is also, I don't know. Oh, okay. I don't know. Then the system should just stop. Docker socket is still there. Okay. Okay, let me stop this and check this status. Okay, so there are two things over here. Okay, when you came across, okay, so let me summarize what I have done first. So, and what I was trying to explain you. So first I stop the Docker, sorry, not this one. Okay, so first I stop the Docker service. Okay, and I check the status, and to stop it, instead of status we could just type stop. Okay, that's okay. Then we check the status by which this one, and after that Docker socket. Okay, so not doctor, Docker socket is another thing, right? We need to stop it, and I mean we don't need to, but I was trying to show you something, that's why I'm doing. So in order to simulate this, the scenario which I'm gonna tell you, so you need to stop Docker service and the Docker socket, and both are now stopped. So now when you first time execute this command, let's say without sudo, so Docker dash dash version. So let's first see. Of course, no harm, no problem, all good. But when I execute this command, so here you could see it gives you the client version. Okay, and when you use it without this, so you say cannot connect to this one. Here it's asking me, is the Docker daemon running? You may encountered a arrow, the permission denied. Okay, so what you can do in that case, you could say sudo, sorry, again see, sudo Docker version. Okay, so I'm talking about your case when you do not use Docker. Okay, but in this case when this is stopped, so you will, and more often, not only because of this, when your client is not able to connect with the Docker socket, so ultimately it is going to connect with this Docker socket. Okay, it is also one of the service inside the Docker host. Okay, inside the Docker host, or I would say the server part of the Docker, right? So always remember, you need to first check the service, and to check the service, we know the status Docker service. Okay, the service is stopped. What we will do, we can simply start this, remove, so sudo systemctl start Docker service, and additionally also enable this. Okay, so what happened when you enable it, when you reboot your server or system, the Docker service is automatically enabled. You don't need to, because if you don't do this and then you reboot and then you come back and you always say, okay, why it's not working, then you end up with the troubleshooting. Okay, so instead enable this, and this is also one of the good practice, I would say, on the server, because when you reboot and when thousands of services on the server, so you don't need to remember what service I have to enable again. Okay, so when you enable and it won't come up, then you will see in the logs the service is not coming up. Okay, so it's better to make them enable. And Docker socket, where is the socket? Okay, so now I'm gonna start this one. Okay, now we will see status. Okay, it's running. Now I'm gonna enable it. Okay, so when I reboot, it will be automatically working. So now if I run again docker version, so you could see I can see the server as well as yeah, server as well as client both. Okay, so always remember, okay, if you do not have access on docker host or server or socket, you will get error permission denied. Okay, and when you configure, or when we configure this Jenkins, I will show you in action how this happens. So for terminal, I showed you how it happened. Okay, so in that case, what happened, docker says here, okay, I'm not doing anything. Once you are done with the installation step, okay, you have all the way down next step. Okay, or here there is also option in the in this section, right? Okay, fine. So post installation step, and when we click on this, we have this many. Okay, and read about this, what is this managing non-root user. Okay, that is also important, but we are just starting, so I will say come back on the latter, but for now just follow the instruction what are mentioned. So it says sudo group add docker. Okay, so before adding a group, I would like to show one thing over here. Okay, and that thing is very simple. Okay, and what is that? When we know, okay, when we install any service, so there is a user created. How we can check that? Okay, that we talk in our day 1 part 3 video. Okay, and so let me quickly show you. Come on, dash. Okay, it's a different keyboard, not English one. Docker I. So what I'm gonna do now, I'm gonna grab a user docker, sorry, group docker. I will execute docker and group, and you could see in your case you won't see anything. Okay, you will see only this much of output. Okay, so if you now if you execute this command again, so it says docker is already accessed. Okay, so when it is not there, when you are installing in other way, then it's a different story. Okay, then you have to perform post installation, right? Then again, next option, it says add your user to docker group. So I already explained you in day 1 part 3 what these are, right? So here in very detail, but here simply we will copy this and put it over here. So but let me tell you what we are doing over here. Here we are adding a docker, I mean user, into a docker group, and this dollar, okay, this, let me first show you. This is one of the variable. Okay, and it gives you the current user. So whichever you are, or whoever or whichever user is logged in, it will give you the that value. Okay, so docker, that's why they don't know which user you are gonna, so that's why they simply say copy, and I mean these are the straps. So and here is also one of the option, right? So very genius people, they created this, right? So we copy this, not this one. Let me go back this command, sudo user modified, we are modifying a user. Okay, we are appending. Okay, don't use this option, they always use in conjunction all together. I explain you why, otherwise this user will be lost their primary groups. Okay, so we are good with this command. I execute this, and after that, when you run this command again, or if you go directly, okay, etc slash group, this is the file, right? Use the sudo, then you can go into the file and you can see this. So after performing this action, okay, you could see your user is over here. Okay, so however you like, go ahead and do that. For me at the moment it's completely fine. So my user is in this, but still if you use the command without sudo, it is not gonna work. Okay, it will still give you the error. So it says log out and log back in this point number 3. Okay, log out and log back in so that your group membership is re-evaluated. But I mean, simple, you have to refresh, right? So instead of that, we can run this command. Okay, so just copy this and paste it over here, and you are done with that. And it says now run this command. Okay, docker run hello world. So we'll come on this. Okay, and still sometimes I observe this doesn't work. So close this terminal. Okay, then again try it. If it still don't work or doesn't work better. Okay, so if it still doesn't work, log out and log back in again. If not, then final option is to reboot, and then you will be able to use your um, docker command without sudo. Okay, so why we talk or spend this much time on this running a command without sudo? So there are possibility, and there was a when initially it was very big thing. Okay, because docker executed command inside the container by default. Okay, they also mentioned this as a root user, and it also has many capabilities to perform. We know root is a super user, right, or super admin, or simple admin, I would say, those who come from the Windows background, which has a lot of power. Okay, so that's why it is not good idea, but that is for the container. But in this case, you are tired of typing sudo again and again. So that's why you added yourself into the docker group, so you can simply execute the command. That's it. Okay, if your use case is different, though it's a very maybe it's too early to talk about to run as a non-root user. So there is a here it says already in the documentation. I will also post this link. Go ahead and read about that. But when you're starting, I will also show you later on, but if you want to read it now, go ahead and do that. For time being, it's all good. Okay, so this is our post configuration. And do you have any questions on this post configuration? All right, no. Okay, well, so I take it as a no. Nice. Let's go ahead and see more. Okay, and what more? So next thing which we are going to see it means let's see. So we did execute our very first command, right? So let me run the same command which says docker run hello world. Okay, so when we copy this, we first, okay, something happened, that's fine. And it says if you see this message, it means your docker installation appears to be working correctly. That's fine. We will talk about what happened over here in a bit. Let me do one more thing. So this process is done. I will execute one more command. So okay, so let me first show you something. Docker build, not build. Okay, so first command, I would say, instead of, I mean, we already tested our docker is working fine. Okay, docker this, when we execute this command, right, docker run hello world, it's showing yes. Now the one of the most command which I'm gonna share with you, that will really important, and that command is docker dash dash help. Okay, and the output just spit out. Okay, so let's go ahead and use the throw less. So why this is really important? When you really don't need to mug up all the commands. Okay, you need to know as a DevOps engineer where is what, right? So that's why help command is very helpful. Okay, so here you could see the Docker commands, and many people have the confusion, what should I learn? There are so many things in the Docker, so many commands in the Docker. So it's really, you don't need to worry about directly execute this command docker dash dash help. You will see what you need to learn. Okay, it's very simple. Yes, of course there are so many things, but you will come on everything step by step. Okay, so very first command over here, it says common commands, right? We also have management commands. We will see this in a while. Swarm is also some of the commands. Come on. And yeah, we also have some other things, other commands. I mean, these are swarm related, I believe. Yeah, so we will see, but very first command, it says run. So I told you very first command is, or the most one, I would say, the not git, docker dash dash help. Okay, second important command, which is you are gonna execute a lot. Wait, let me share this with you in a chat if you are. hmm, yeah, docker help, right? Second command is the, when I execute this one, right? So we have run command. So let's see how you can use this command as well. Then I will show you more details further. So docker run dash dash command. Okay, and again it out lots of content. So we go ahead and use less. We already talking, and I use a less a lot. We in our day one Linux. So here is the how you can use or how you can take the help of this terminal. Okay, you really don't need to go anywhere, right? So right on, every help is available in your terminal. Okay, so let me go ahead and a little bit just speed up, so otherwise we would be only talking about the basic stuff. So this is one command, and it says these are the aliases for this: docker run and docker container run. Okay, all perform the same, right? Same. It says create and run a new container from an image. All right, so why I'm saying this is second most important, because you will realize end of the session I execute docker run several. Okay, so that's why first is docker dash dash help, second command is docker run. Okay, if you want to see what or how to use help, so for example in this case docker run dash dash help we executed before, and what else we can, and here you have other options as well, right? We will see what these options are. A is attached, dash c is CPU share unit, D is detached, I is in is environment variable, right? I is interactive, ln, all our stuff, right? So this is one of the things. Now I showed you before, right? When we run the docker run, right? This command we executed right before, docker run hello world. So we know docker run is to create a container, and it says from the image. So this was a image name, right? So what happened? Let me show you. To see a image. Okay, so there are some in this. I mean, I'm gonna talk about 10 to 15 very important command. Okay, but I don't know in which sequence. So I will execute one after the another, but I will explain you everything. So docker run. So to see the images, we have a command docker image. This is one command. There is another command, you could say docker image dash ls. Both give you the same output. Okay, so I'm used to with this one, but again this was this. Okay, again it was my interview question, so I still remember, and it was very early in my career, right? So these are both the commands by which you can check the images. And now let me little bit make zoom of it. I think it's enough. Yeah, so this column, or right, it's a repository. sorry, let me clean this. Docker image alias, or you can also run Docker images, whatever. Here you could see the repository. Okay, so it's saying this, it's a stack, it's a latest. We will also talk about the tag, what tag it means. Okay, by default consider tag as a latest. Okay, the same funda when we talk about when we discuss our git and github, right? The tags. So similarly these images also have tags, right? Because I'll come on that later. It has image ID. Okay, it says created 54 hours ago. Okay, the size it's 202 MB. Okay, and here if you see hello world, right, and it has 5.2 KB. Let me pull one more image, but before that let me pull it. Docker. So this is our another command, docker pull. Okay, and docker pull, by which we can pull the image from the registry. So docker pull, let's say Ubuntu, right? So done. Now see, so it says using default tag. Okay, so now you got it, default tag. Okay, if I don't specify anything, this is the default one, and it says pulling from library Ubuntu. It says already exists. Okay, but we cannot see it, and why it's so? So when we talk about our builder section, we will create our own images. Then I will let you know what it is or why it is saying the pulling from the library and already exists, right? So but it is what this means. Okay, we will talk about this but hold on for a while. But another important stuff is status downloaded newer image latest, and I told you if image is not right in this diagram, where is it? If image is not available, right, I have performed this one docker pull, and it via this command I contacted docker daemon, and docker daemon did not find the image on the local, right? That's why it says um, pulling it from the this one, pulling from the library Ubuntu. And if we don't specify, and of course we install the docker, so by default there is, I mean, of course you can specify the registry or the address or repository, or however at the moment we are starting all good, but it says registry, so we don't specify. So by default it will go on the docker and download the image from there, right? So that's what it says, docker.io library Ubuntu latest, right? Right, we will see this. We will also create our own repository, not registry. Okay, so we will see all this thing in it. So that's how the image pool works. Now when I execute docker images, so we use ls already over here. Here I use docker images, and now you can see the Ubuntu is also showing, and it says 101 MB, and hello world is like this. But it's okay, it's a hello world, but it did not have much information. But Ubuntu image is 101 MB, and when we downloaded the Ubuntu latest, I mean, of course it's a latest, so it was around 4 GB. And if you go on the Ubuntu website, so like Ubuntu Studio, it has around 7.5 GB or something in size, and other thing as well, right? So size is 10101, and here the size is 202. And let me show you one more thing. I talk about in our day 3 part 3 session, right? Alpine. So I say docker pull Alpine. Again the same process. Okay, there was no image, so it went back. It says pulling from here, and registry is here. So if it is being asked how you can identify your registry, so you can, for time being, this is could be answer. Well, you pull the image if it is not available on local system and it pulls from the remote, then you could see the docker. There are other commands as well. Okay, I will show you that later. And now let me do like this images and see same one, Alpine, which is in 8.17 MB, and if you see Ubuntu, which is 107 MB in size. So that's why I told you to start very early, right, with the um, Alpine. That's why I showed you in day 3 how to use Alpine, and that's why I emphasized you should also, I mean, apart from Ubuntu, you should also look into the Alpine and most of the. But you are starting, it's good to use with the Ubuntu, and if you don't know how, or if you don't feel like doing Docker or containerization thing with the Alpine, it's completely fine. Okay, you really don't need to be worried about. Okay, so we will see when we create our own custom image, but at the moment I think you should know this many or this much information. Okay, here you could see the size. Okay, and there are so many other benefits as well, but you could see my image, these two images which I have created. I'll show you in a bit what these are. So it has 202 MB and it has 20 or 102 MB in size. Okay, and these are also based on the Ubuntu itself. Okay, these are not based on the Alpine. So it really okay not to be okay, I mean, not to use Alpine, but I would encourage you, I would recommend you to go ahead and use this, because when you will be doing pipeline thing, Alpine images are very small in size. Okay, which definitely improve this, the optimization part. Okay, so but if you are filled with this, it's completely fine. So but Docker command works for all the Docker images. Okay, so main thing to remember the Docker command. So that's how you see the Docker images. Now I'm gonna run a container out of my Docker image. So 313. Okay, let's see. Let me show you first this one. Docker run, and this is my image name. So it just give a welcome message, nothing else, right? Second thing, the second image which I run, this Docker run, and this is the image name, right? And how we can check the image. So we have command Docker images or Docker image alias, both is same, and I would say like this. So you see it's just showing everything, right? It is not good at all. Okay, let's get started. And here it says loading, right? So I show you there was a reason. The reason is to first show off I could create cool images. That's not the reason. Okay, so we'll come on that why I showed you these images. Okay, remember the this kind of out. Okay, so I have some of the options which I would like to show you, and for that I believe that would be better choice. But before that, uh, Docker images. Okay, and you could see we are going to use Ubuntu image. Okay, so this time I will create a container Docker run, and let me just say Ubuntu. And if you could also type like this, okay, then it will perform the same thing if you don't do like this. Okay, so when you pull the code, right, it perform the same thing. Similarly, automatically it consider the version or tag is latest. Okay, so I have done this. Docker run this. Now we have next command, Docker ps. Okay, so Docker ps, let quickly show you. I know what is this for, but if you want to read, and there are so many other options as well that we are gonna use very shortly. -A, right? So Docker ps is to list a container. So that's what we are gonna do now. So far I have run 3 4 DSOC3. Once again, Docker images. So I have run container with this image, with this image, with this image, and with this image. So 1 2 3 4, we could be seeing the 4 containers. So we have command Docker ps. Wow, and we do not have any container at all, but we have option dash all. So I would say -A is enough, right? And when we execute this command, let me adjust the terminal so we can see, and clear -A. So first is your container ID, first column, right? Similarly, when you execute the command Docker images. Okay, so first it was showing the repository, it means the name of the image, sorry. And similarly here you have container ID. Okay, then it says image, so this is Ubuntu, and we have the same, right? And same DSOC 3, DSOC 3.1, and this was is the hello world, this container. So it has the container ID. In this it says 16 minutes ago, 2 minutes, 2 minutes, so 16 minutes before we executed the command hello world docker, and that was the container. But all these containers are in exited state, and they have also a name, right? So it has modest, what is this, Roslyn, okay, great L, or okay, whatever. I'm very cool with or I'm fine with the container ID, so we will use this one. Okay, but this got exited. So what happened over here, both the command, even though when we execute this container it also gives us some command on the terminal like this and exited after that, right? And we don't want it to get exited. So what we can do, we have more options, let's explore. That's why this section is, no, previous was explorer, this one is navigator. So docker run help, I know, but still I want to show you how you could use it. Okay, so we simply run this command. Okay, docker run and the image, and same you can see in uses is also the same, docker run and the image, rest everything is optional, right? So we have done that, but still the container got exited. We want to enter, I mean we want a container, our container should be running, okay, not should be exited, right? Then we have the option, we'll come on this. So here is option which is the interactive. Okay, so keep std in open even if not attached. So yes, that's what we want. And we also have option T. So it also says it provides you a terminal, right? So we use dash I and dash T option. Let me show you over here. Docker run Ubuntu. So here I will say dash I dash T. So what I am actually doing, I am running the container, and this dash I means interactive and dash T it means, so the terminal which I'm executing this command. So I'm attaching this terminal with this container. Okay, now you can see I'm inside the container. And why this so let me open one more and let me execute the command docker ps, and now you could see docker ps, it's showing me a different output, container id, this and status up 9 seconds and created 10 seconds ago, right? And its name is sleepy saha. Okay, but a special thing, if you see over here command, okay, maybe, okay, let me confuse you. Okay, so what I mean, this is the thing, the command, as I told you when explaining you about the container. So container are meant to be for a specific purpose, okay, and whatever you want to perform you need to mention in the command. So in this case, when we spin up ubuntu container, then this command bin bash is executed, okay, and which really doesn't do anything. So when this command is executed, it find, or it start to look for some kind of terminal, right? So now I'm inside terminal. How I can see hostname maybe, okay, and this one C9C6025 and all this is C9C1638. So my container is the same, right? I'm inside that. I can check who am I, right? I can say ls, it's ls-lrt, right? So all these commands which we executed by installing the virtual machine, I can install in this, right? Let me see if I can execute disk free dash h. Wow, isn't it amazing? Like once I practice my, so for example, now I'm working on I'm working on Ubuntu, or I'm learning Ubuntu. So I simply say docker run right? So what command I executed over here? Docker run dash I, it means interactive, I want to interact, and dash T, it means my this local terminal, this black screen attached with this container. Okay, that's what I'm telling to Docker, and that's what Docker did, and that's why we are over here. And now guys, I told you why this sign was important, right? Very start, right? So it's still you able to see root at the rate this container, but in some of the time when you have don't have shell, then you will not be able to see this as well. Okay, you could only see dash or dollar. So by simply you can see, okay, the hash prompt, it means it's a root, and that's why I'm able to execute this command, right? Okay, so now it's a question time. I okay, Francisco, go ahead.
Yeah, sorry. Where we are right now? Sorry, I just lost myself. We are inside the container, right?
Yeah, right.
But which one?
Yeah.
Because I followed you, and as well me, I am in a container, but I
Oh,
don't understand which one.
yeah. Okay. I'll explain you, and Pradeep also will. Okay. Let me first see. Oh, there are so many questions. Let me first address the question which is more relevant for this situation. Then I will go again. Okay. First of all, I appreciate Pradeep, Francisco, you, and of course Anish for your attention. So you asked the question, and this question is why they have different random names. And see, it is also related with the Francisco, which he asked how I identify in which container I am, right? So what actually this is gonna be our next command, but you asked, so let me show you when I executed this command. Okay, here when I execute this command, okay, so what happened? Because of this dash I and dash T, because of this, Docker run the container, and as well as it runs, it put in interactive. That's why we are here. I'm able to type the commands. This is interactive, and T, it means terminal. So Docker has attached the container terminal with this. And now the question is how you can identify which container you are in. So this command, right? This command is directly land you inside the container. If you want to identify which container you are in, for example, here there are 100 containers. So how you identify, right? It has random name like Pradeep asked. So this is a default behavior when you do not specify Docker explicitly or implicitly, not explicitly, provide a name from its own side, but more this container, right? So let me do one more thing. Mm, interactive, let me give it a name, dash name. Okay, and name is not Ubuntu, otherwise it will be confused. This of 3 or not this one, my first container. So we know we can provide our own name. Okay, so this is the syntax. This is Docker command, Docker run, because we want Docker to run the container. This time we want it to give it a name, and this name should be like this, and we want Docker to use Ubuntu image. And as soon as I hit enter, I'm not inside the container. Okay, and if I say Docker ps, so my container is not showing. So what was the name? My first Ubuntu container. And if I do like this, so here there is a name here, you can see. Okay, so it got executed because of this command. So I will show you what this command means, but at the moment just ignore it, right? Because I think it's not a good time to explain this. Okay, for the moment, just consider this as a, it is something which requires to be attached with a terminal. So by this command, we are asking Docker, okay, when you execute this command inside your container, okay, and you're looking for the terminal, so you can use our terminal. And not only use, we also want this terminal to be used, or type something. Okay, So that's what it does by -I command. And when you say -T, it means the terminal. So that's why we have to provide both the option over here. I know it's confusing. That's why I have created my own images, two images to show you how this commands work. Okay, right? So, and the random name, that's why it is showing the random name. So what I can do this time, I create this command using like -I op and T. Okay, I can also use like this, or I can also use like this. Okay, so when I say like this, it says yes, fine, lucky moment. The container name is already in use, so I can use my not first, my second container. First got filled, so my second container, and now I'm inside the container. Okay, let me open one more and make it little bit 20, 30. Yeah, 30 is okay. Docker ps. Okay, so we know Docker ps command gives us all the running container details. So this time you could see my second container is popped up over here, right? So this is how you give a name to your own container. And here I was talking about, I mean, first of all, um, we are not done. I will give you more insight, because when I started, I was literally confused with these options, -I and -T. What are they doing? Where I am? What is happening? Okay, so don't worry, I will explain you more. And that's why our this part one is completely for the foundation. Okay, so but here the point is, if I want to learn Ubuntu, I can do this. If I have something else, so I can, let's say, Docker pull CentOS, right? So it has started, it's pulling, it's downloading, right? And it has started to download, right? And next time again I say using default, it says image is already up to date for the CentOS latest, right? What if I want to use Rocky Linux? Let's see if something is there. So manifest unknown. I don't know, Rocky OS or Rocky Linux. But anyway, we have downloaded Alpine. We can use that as well. So let's run a container out of the Alpine. Run this one dash. We will do that later. -IT and Alpine. Let's test. Okay, so see here, you have this Alpine doesn't give you any of the information where you are, right? Even though if you execute, so directly you are at slash, which is the top level directory. Okay, when I say ls-lrt, so instead of, my point here is, right, when we did the comparison, I really didn't want to make you too much bored just showing the presentations, right? So here my point is, when in case of virtual machine, you have to configure. In case of container, what happened, we simply um, just install a Docker, right? And after installing a Docker, what we have done, we are just pulling the image and running the container. And once I'm done with I don't like, okay, I'm not useful with Alpine, I don't want, or I don't like to learn, or I don't want to learn Alpine, no, it's not my thing. So I can simply say exit, and I can say Docker ps. Okay, so, but it is not here. And now the container is gone. I will show you how you can remove as well later on, but it's very simple, right? You can simply pull, try it out, exit, right? So it's pretty much simple, and same commands you can also execute over here. So let's see what happened if this, there is a, or let's check the SSH, sudo system ctl status SSH, and sudo, it says not found. Yeah, okay, because sudo package is not there, and we are running this as a root, but it says systemctl is also not found, right? So that's why when I showed you that diagram in on presentation PPT, so I told you we do not install operating system in container. We create container are not full-fledged operating system. Okay, that's why here systemctl does not need it, and systemctl package is not here because, but when you execute this command ps or maybe ps-aux, oh, sorry, ps aux, so you could see user is root only, there is no other user, and we know this command is for all users, right? Dash a, but in this we have only, and that the thing I was talking about, the command, right? Slash bin slash bash. Okay, we will go this more detailed when we create our own image, but I'm just enabling you, preparing our foundation when we go to that level. Okay, so you should not, I mean, at that time you would not be wondered what happened, why we are doing this thing, what is happening when I talk about command, right? So here systemctl didn't work. Let's say, do we have vi not there, vim no, nano no. So guys, it's a buffet. Okay, it's not like that. Okay, when you come you have to take everything, right? So but still I can do apt update. So so apt is important, right? That's why apt command is getting executed, so this package is there. Of course, without this, how we could do the further things with that. So it is done. Now I would say apt install, and I do not need to use sudo, right? Because it's a root user. Okay, I have taken a bigger example, but that's completely fine. Let it be. Talking about, right? So Pradeep says use stop, so top work. Okay, and in top also we got the same output, right? And now as we install vim editor, so I should be able to execute this command, and we know when we have vim, so I can create file one, and this is just just nothing, right? And I can see
the Vim works.
Vim works because we install the Vim over here. Sudo apt install Vim. Okay, that's why.
Yeah, it works.
Yeah, it worked because we installed. Before it was not there, right? So maybe let's try the Vim. It is also installed. It's a part of Vim, so that's why this is there, right? So some of the things which is not here, right? And what is here, you could, we know by this directory, and that's why we talk in our Linux day one, what is the significance of the directory. So we know by that, okay, all the configuration is dash etc, so you could check what are the services is already the configured on this thing. But if you go in system or somewhere else, you will find the more inside. Okay, so I think we this root of ptm multimedia, but yeah, that's fine. So that was my point, right? I would like to show you, and if I do docker ps, so you could see I have come out of, oh okay, I didn't explain. So whether you can type exit itself, or you can also type control d to exit out of the container. Okay, and that container got exited. And now if I go back on this terminal, and if I execute docker ps dash a, so I could see my container got executed. And how I can identify, so I did not uh, given a name, so I can simply copy this, and say control f, control shift f, control shift v, this container. Okay, and it says up, Now what happens? Okay, sorry, wrong screen. I was checking over here. Control Shift F. This one. Yeah. So it has exited 27 seconds ago. And Sleepy Saha. Yeah, that was the container. So this is how you play around with the container. But what if I don't want it to be exited at all? So we have other way, right? But before that, let me exit this one. And if you see, we have a lot of containers over here and which are not running, right? So we can remove those container. Okay, and how we can remove those? So I can type the command. Let me come over here on this. Control Shift F. Okay, I don't want it. Let me make a little bit. This one. Okay, it's enough. So I will remove the container. We have Docker RM. Okay, and you can also remove images as well. So let's go ahead and first do that. Sorry, my bad. Docker images and its image. So I don't need Alpine at the moment. So I copy and Docker RMI. So RM is to remove and I is for the image. It says Alpine and it's a Alpine here. Error response from daemon. So see, when we execute a command, it contact daemon, right? And conflict unable to remove repository reference Alpine. Force container is this one. I mean, what it means, this container, I mean, this image is being used by this container. Okay, so in order to remove this, first we need to remove this container. So what we will do here, I would say Docker and RM, same command. For image, you have to use RMI, and for container, just use this Docker RM and container ID. Okay, that's why I said container IDs are good. Now I'm gonna remove this. So you could see it says untag, untag, and deleted. Now if I run the command Docker images or image ls, right? So we do not have, or Alpine is no more. Okay.
I still have it.
Okay, so I think Francisco, this will be good for you. You really don't need to rely on the virtual machine at all, right? It's very easy, not much resource consumption. So now let's go ahead and remove more. So for example, if I would want to remove images of DDD Docker, not DDD Docker, Docker RMI, and I would to remove CentOS, Control Shift V, Control Shift V, Hello World as well, Control Shift C, Control Shift V, and Ubuntu. So we are gonna get an error. Can you guess where we get error? Quick.
What?
When we remove Docker images like this, Docker RMI, CentOS, Hello World, and Ubuntu. When I execute a command, we are going to get some kind of error message. Can you guess? Let's see. So here,
Yeah, I have anymore.
yeah, hello world. Okay, of course. So we still have these containers. Okay, those who are using these images, but CentOS was used by any of the container. That's why the image got deleted. So now, if I say Docker images, right? So I still have this two, but I need to remove this two container. So instead of doing this way, we can say Docker ps dash to list all the containers. Then I could say Docker rmi, no, rmi is for images. So here in status we can say exited. Okay, so what I can do, I forgot there is a command by which you can directly remove the exited container, but before that we can see one more thing. So I can simply copy this, or instead of removing one by one, I can simply copy this. Okay, like this. Remove. Then we rm remove hello world as well. And now we have this tree, and this is up, these are two exited. So let me remove this as well, and we get rid of okay, fine. So we have only one container which is up and running 4 minutes ago. Completely okay. Fair enough. And now what next? So I have shown you how you can list the container, right? How you can list the image, how you can pull the image, right? How you can check the image. And I didn't show you one thing, Docker PS. Let's run one more thing. So before I go ahead, I'll show you one more thing, -I-T option. So that's why I had created this Docker images for, right? Um, Clear the screen. Docker. So Docker run, and let's run with this one. But which one is which one? Okay, so loading, that's fine. And instead of that, I will first let me show you again Docker images. And these images are created by me. These are not available anywhere, but I will push that, right? Or I will also share with you, right? And instead of using this Docker DSOC3, sorry, so it didn't find anywhere, of course. We use this one. So when I execute this, so it is simply giving me this output. And now if I see Docker PS, so I must see a container, right? So these three are the container. Docker run, let me give it a name, echo message. Okay, so it's a simple echo message. And if I see Docker PS, and if I give the name of this, okay, so, sorry, wrong, my bad. Docker PS nothing, Docker A, this one. Additionally, we have one more command, and that command is but I'll show you later. But here what I wanted to show you, this image is simply performing this thing, right? So we have given a name, but let's talk about especially -I and -T option, which is really confusing and what it does. So for that, first Docker images, and I'm gonna use this image which I have created and which is on my local system, not available at the moment anywhere, but it will be. So to run the container for out of this image, I have command docker run, and name, and interactive and terminal, and I'm gonna use this image. So let's see what happened. So what command I execute? At the moment, I did not use -I and -T option. I only used the name one, and we got this kind of output, right? Correct? Welcome to DevSecOps Club and further things. But now, when I use this option, -I, let's see what. And interactive terminal 1. So we are asking Docker to do it interactive way. But what happened? It got stuck because it did not have the terminal, right? Now that's why I told you we need to use both the option altogether, but let's use it without without I, and that is container 2. See, now this is changed, the output color is changed, but what happened? It wait here, right? Because it is executing. These are the sub. I'll show you what these are as well in a uh, Docker file later on, but I have executed some of the things inside the Docker container, and for that, these are the coloring convention of the shell script, right? So before, what happened, I did not it include a terminal. That's why it was giving us the output in a white, right? But when I provided the values of the color, so container was able to get a terminal, and that terminal is this one, this terminal, and that values is converted in this color. That's why we have this output, but our input has stuck over here. So I to simply type Control C, and this time I will use dash I and T all together. I'm sorry, this message really got long, but it's okay. I will make it shorter. Right now, simple, very smoothly it got executed, right? And it says welcome to DevSecOps Club, and it's a bear, and let's get started to your DevOps journey, and yeah, kind of promotion. So let me type this name over here and see interactive terminal. So because of I and T both the option, it was able to, or it was stopped at that one. What is your name? I've given the name, and after taking a input, it says welcome, let's start, and all the same thing ready to go. And when I execute it again, of course it is gonna be something different. So I have another option. Instead of giving a name, I'm just doing the testing. I'm using this option dash rm. Okay, let's see what happened. What is your name? So my name is name. My name is name. And it's performing the same thing again and again, even though, so see, these colors are getting changes again and again. So when I don't use I and T at all, so I will get this message. I will get the same message because it is getting executed inside the container. Okay, but that container terminal, container shell is not get attached with my local shell or local terminal. Okay, that's why it was showing something different. So I hope I really put a lot of my brain work to and how to show this, and yeah, this happened. So now when we interact, when we use I mean when we use dash I and T, and yeah, it's a right. So that's how you use Docker run. Okay, so another commands I would like to show you over here. So let's first see this dash rm. So I have created so we should have Docker ps, right? So we do not have any running container, of course, but we should be having many containers over here. So container 1, I did this, container 2, container 3. But what if I don't want container to be exited? I want it to be continue. Okay, I don't want container to be exited after performing the task. So I have another command over here. So let's copy the same name, let's say 3 4. There is option D. Let me remove this. And now what happened, we just got a ID. Okay, and this ID will match. Let me show you. Docker ps, come on. Yes, I got it, why it happened. But anyways, what happened, the same thing is happening again. Let me show you. When I executed the same thing, right, and it executes this one and get exited, and all good. So let's try with this one. Why not? I didn't try actually, but I believe no. Same name 5. Let's see. And okay, nice. Okay, I didn't try it, but the logic here is, if we don't put this and we want it goes in detached, then here we can provide some more inputs, right? So like I provided this one. Let me try one more thing. here. Mm, 6 and 7 one. Fine. So if we use detach as dash dash it, then our container will come up again. So now we want to see the logs. So Docker logs. Okay, it's a plural again. Remember, I'm wrong. And you can see our output is right here. Right? It's just welcome message. And let me see again. Docker ps. So Docker logs. So Docker logs is the command, and which was tire 6. Of course, it will also give the same, but in different color, right? So this is one of the way by which we can check the log. Additionally, but we don't have web server, but there is one more way I'll show you in a bit. But I would like to show you before that some other commands. So Docker ps, I want to stop the container. So I have option Docker container stop, and I can use simply a Docker name. I mean container name, sorry. It is gonna be stop now. Any second. Thing, let's check whether it is stopped or not. Yes, it has done. And we know when we stop, it should be go into dash a1, right? I mean dash a, it means Docker ps dash a. When we execute that command, then it is gonna be there. So I will do Docker stop again, and this container. Okay, I'm very used to with this command. Right before this content, I mean this command was not there when I started, right? But now we have this one, and I would recommend to go ahead and use this one. Okay, these are also fine. You can use it, but it's better the future use the things which is more better. That's why we have newer version. So Docker container, and I also try to use this one and start, right? So I'm gonna start first 6 1, or let's say 7 1. Why not? Anyone, it's fine. You can do that. And Docker docker and ps, and now you can see my container 7 is started. And this time if I check a log, so I can of course check a logs, Docker logs and container name, and it will give me the output like this. Okay, welcome to DevSecOps Club. And so this is to checking a log, starting a container, stopping a container. Now we will see another thing, and that another thing is to removing, right? So I think we already removed, we already saw that. And what else we have missing? Docker ps, Docker stop. Let me copy this container name and let me stop it as well. And I would like to show you something else here now. So you can do this kind of real practice. Okay, not just to run, but these are also practice. Okay, I say Docker images. We do not have any image. Okay, so Docker pull, and I'm gonna use nginx, nginx. Okay, so once Pradeep, you asked a question, difference in Tomcat and nginx. So nginx is our web server, right? And Tomcat is a special server for, or engine for Java based application. So our image is there. Now we run this command, Docker images, and we have nginx over here. So I can run the same, right? Docker run. I can give a name. Let's check what name available. But yeah, why should we check? If name is already exists, it will throw us an error. So Docker run, I will give a name, web server, and from the nginx, let us. I just hit a tab button, so it auto completed, but it is really not required. And I have done this, right? Now what happened? My nginx is working, and we know web servers are working on port 80 and 443, but we do not have any I mean, traffic is not encrypted or didn't we didn't make any of the configuration. So let's go ahead and see on local host what we have. Local host. Okay. See. So this site cannot be reached. Okay. So reason is pretty much straightforward. I hope you guessed it. If not, let's go ahead and see. So what happened if you see on this? Let me run one more thing. So okay, let me show you first this here. So it says port 80, right? So port 80, it means the port it is showing here. Okay. So this port, this one, this is a port of this one, right? This is a port inside the container where this nginx is using or exposed, right? This port is exposed inside the container, right? So what, how can I see? So you could see the docker entry point or something. It's dot, it means it's a kind of script inside, right? So inside command we can also put a script. We will make it our own, but don't worry at all. Now I wanted to show you something else at the moment. And additionally, if you see, I cannot do anything over here, la, but still it's not working. So I have to press Control C, and as soon as I press Control C, my container has got exited, right? So in this kind of scenario, we have option detach, right? So we can use option detach. So let me remove it first of all, clear the screen, not remove. So here I can use dash T. Okay, strange. Let me remove this. So I showed you, right, how we can have the name. So I'm correct. So Docker, once again, Docker PS. Okay, my nginx is back again, right? But with the different name, that's completely fine. And still, if I go, okay, so I still am not able to access this, even if I specify the port number. So the reason is, one, we have fixed the one problem, right? Our nginx go went into the detached mode, but port is not still accessible. And this time what I will do, I will use option. See this carefully, guys. Here, dash. Yeah, it's a little bit not. The pixels got a scratch, but that's okay. So 8080. First, let me make you confused. After that, I will explain you. Okay, so this time, what I have done before, I did not use dash p, but this time I also use dash p. Okay, and the command is the same, no difference at all. Hit enter. Let's reset the terminal. And if you go again over here, this one, this one, this one, this one, which one? Okay, let's go. This time, if you see in the port, it's a different, right? Here is the difference. I don't know. Will come in, otherwise we'll make it violating here. So this column, come on, we'll make a better version of it. Just see over here. So before in ports, we still we have 80, but this one, right, it was also before. So this value was the port number of your container. Your nginx inside the container is working or running or whatever you want to say. Okay, but when we use dash p option here, right, why not, let me make a little bit zoom. I think that's enough. So when we use this dash p, it means we expose port number 80, and then if I come, so already it's there. So let me close it and retry it. Local host. So by default it goes to 80, right? And yeah, and it says if you see this page, the nginx web server is successfully installed. Okay, nginx. But here what's the catch? I'm using the port 80, let me run again. So of course, what happened, we will see what happened behind the scene in part 2 in very deep dive. Okay, but at the moment just wanted to show you and you focus on the command. So it says port is already used, so you cannot use the port. So what this mean, which port, this port or this port? Okay, and this is where the confusion arises initially. Okay, so that's why what I'm gonna do, let me put 180. I'm gonna do one more thing, 280, now 380. I should be seeing 4 containers now if I execute this command. Yes, so 180, 280, 380. So let me show you in a browser. The localhost port 180 nginx. Let me duplicate this, and this is running on 280. Yes, and make a duplicate of it instead of typing lazy person. Okay, so we have 4 instances of the nginx. One, it's running on port 80, which is over here, right? Second one is 180, which is over here. One is 280, which is over here. Third one is 380, which is over here. Okay, so you can see I'm using the same nginx server which is running on port 80, and I'm using the 5 instance of that. If you install nginx on your machine, right, so port 80 will be bound and you will not be able to use the port number 80 again, right? So that's how this is powerful. Okay, and here the confusion which I have created using this one and many, where you'll find the same thing. So first port is your port, and remember this is port of the container, I mean the port of the nginx or service which is inside the container, and this is the port where you are accessing the service. And why this is important, this is also important for Kubernetes. When we are going to see the Kubernetes, right, then this is gonna be um, very important. So always remember, second, I mean, when we expose, that is the command I'll show you, right? So this is, I mean, first your preference. Okay, remember like this. So okay, let me remove this. So first is your preference, right, and second is container preference. So remember like this, or keep in mind, or maybe make your concept in that way. I'm used to with this, so but yeah, it's a very confusing thing to remember what is which port. And when you see actually especially, yes, you are executing the command, that it's fine, but when you have thousands of container and you see the same output, where is that, like this, so how will you identify which, right? Of course in this case it's the same, but when you have 8080, 9090, or 8080, or other ports as well, okay, 5000, 5000, 420000, or like that, right? So that's very confusing. So always remember, this one is your preference, your choice, how you want to access the container. Okay, this is the default or defaultedness which is inside. We can also make these changes, and we will do it when we create our own Docker image then. But by the time it's completely fine, it is from the nginx, and yep, that's how this nginx works, right? So this is port thing. And what else I showed you, uh removing container, listing container, run container image listing, starting, stopping, logs I showed you. Yep, let me show you the logs. One more thing with the logs. So let me choose. There is option -f which follows the trial, right? So we will be using nginx, and let's see if we have some name. Let me use this name. cool pest tower, whatever. So, oh no, here. So, Docker logs, it's not doing auto completion, dash f, and so dash f, it means it's simply a trell, and which container I copied is port to, no, 380. Okay, so as soon as I have more requests on this, right, 380, so you could see the logs are coming up. So that's how you can trail, like if you are doing troubleshooting especially and setting up some web server, so this command is really helpful. Okay, so when you have 2 3 4 monitors, right, so on one screen or one monitor you are having this one, right, and second you can see the logs and do some troubleshooting. Maybe you could go in inspection, or I don't know what you want to do, maybe check over here there, whatever you want to do. Okay, so this command is very helpful, right? So I believe that's enough for the today. I showed you the commands which I wanted to show you as a beginner, right? Docker ps dash, let's say dash a, oh come on. Okay, so these are our running containers, and now I will have to stop all of them. So I will do docker container stop, and copy this one by one and stop them all. And okay, so all container got stopped. Now docker ps docker ps dash a. Okay, so a lot of, so what I will do, docker rm docker ps and all, then exited query, exited, what is the status, exited. Okay, okay, let me give you this one when you are doing practice, and I must believe you will have a lot of such kind of situation. So execute this command. Okay, there are other ways as well. Yeah, so we are, I believe we do not have, oh wow, so it's again created, and I think it's a created, oh yes, one thing I wanted to show you, one more thing. So we created one, there is one command, right, docker run. Okay, and another command is docker create. Okay, so both perform the same thing, create a container. Let me show you here in help. Oh, no, I'm tired. Docker command. Let me show you 1 second. Docker create. Sorry. So see, Docker container. It says alias. So Docker container create or Docker create container. So this will create a container for you, and Docker runs also create a container for you. But in Docker run, it creates the container as well as it runs the container. I mean, it starts the container itself. Okay, so when you have a use case, you want to just create a container, want to configure later, so you can use command create. Anyways, I wanted to show you, so I just showed you over here. So I always run docker run, it's completely fine. So there was a container docker ps and dash a. So for example, let me see this and show you. So it's gone. Okay, it's over here. So simply I can say docker start, or and then it will give the container id and it will be start. Okay, so if I want to remove this, docker container, it's long command, rm and container id. One more thing, if container is running, so you can do like force and forcefully remove the container, or same for the image as well. Okay, so I believe yes, that's it for today. And today what I have shown you, the important commands. Let me quickly summarize and then we wrap up, right? So very first thing, docker. First command was the version, right? Second command was the docker version. Third command was the docker info. Third was docker run. Okay, and to run you need, name is optional, you need a image. Okay, image name. So while I'm guys, this is convention. Okay, in Linux or like this, if something is written like this, it means this is optional. Okay, so this one is optional. I mean, sorry, not optional, you have to provide the image. Sorry, not optional, you have to provide this. Optional is in rectangular bracket. Okay, so docker run and image name. And with docker run, let me copy this. So with docker run you can use, okay, -it all together. And let me copy this, why not entire image name. And you can also use a detached mode, right? I could also show you docker run and -p. Okay, your choice. So your port choice. Okay, see, see. And then container choice. Okay, container choice. Yes. Okay, so this is the port related command. I also showed you um, docker. And if you have to run everything in one go, so use detached and port. Okay, that you into combination, right? If you don't want to see any logs, but if you want to see logs as well, you are doing configuration, then use only this. But you want, okay, I know my container is working fine, so go ahead and use this -d along with the -p. It will go in detached mode. I will also show you the docker logs command, right? I have also showed you docker rm to remove a container. I would also show you docker rmi, right, to remove images. I already shown you docker docker. Then what, ps to list the container, right? And docker ps-a to list exited container. Okay, this, remember, don't only remember the command, remember the purpose of this, because this is interview question. It could be asked, okay, how you check the exited container, or how it might be, maybe let's say it might be asked, okay, how you restart your stop container. So it means it asks for two things. First you have to check the stop container, then you have to start, right? So we also have this option docker container, right? And this is also, and when you run after this command help, sorry, help, then you will get more, right? So these are the some of the command to docker run, right? So you can run the container, you can pull the images, you can see the images, you can stop container, you can run, you can see the logs, you can remove images. I think I already told you. So yeah, I believe these are much more, or not much more, but yeah, that's enough. Try, okay, to play around with this, because in next session we are gonna create our own image. This is just a basic, it's like our Linux basic commands. So this is just for docker basic, nothing, I didn't show you anything this. But in order to use the docker at in full potential, we must know this command, right? So now your level, I would say. So please practice, okay, at least for this command. These are just 9-10 commands, nothing else. Okay, and to explore, write the command and dash help to explore more things, right? So with that said, let's go back. Okay, so that's what we covered today: docker installation, post configuration, my first container, then my second container as well, and we create and run the container, pulling container images, right? And of course we list the, and I already summarize all these things we have done. Okay, next. So next is our builder and captain. Okay, that we are going to cover in part 2. So these two sections are just for the basics, just for the understanding what is Docker. I cannot complete one thing because I wanted to share with you a lot of, I mean, lot, it means the very, very important thing. So that's why I divided in this part 1 and part 2, right? So here, this part, now we know how container is there, but in part 2 we will go more deeper into the commands which we executed, what the daemon means, where it happens, what it happens. We also see the commands container d shim and all these things we will more see deeper into, because container is the base for our Kubernetes. Okay, so that's why I put this in a right before the Kubernetes. And many people ask, should we start containerization, I mean container first or Kubernetes first, what should we? So I always say go ahead and learn first the container. It's a reason you will also realize. Okay, so that's what we will do in and next section, and this is the final time if you have any questions. Okay, so I take it as a no. In case if you want to contact here. Last thing, again, social media links. If you are, if you want to go ahead and connect. Once again, big thank you for love, for support which we are receiving, and special thanks to you guys. Today's session is really, really amazing for the, because of your participation. I could see all the chats which I saw, I mean questions which you put in our chat box. That's really, really amazing. That make me show you more stuff. Okay, so thank you very much for that, and big thanks again. And once again, big thank you, and see you each other next week. If you,
Thank you. Thank you so much.
and
Thank you so much.
you guys welcome, and please do practice, and that we will be diving deeper into more advanced thing next week. Okay.
All right.
All right.
Thank you very much again.
Yeah. Bye bye.